Hello, students. This is Mr. Ezra. We are going to continue our unit on statistics by introducing something today called the normal distribution. When we talk about that word distribution, we use it a lot in statistics. We might say a distribution of the sample data or a distribution of population data or a probability distribution. But distribution really is just like a collection of data of some type. And there are many distributions that we look at in statistics. One very special one is the normal distribution. And let's talk about some things that make it special. The normal distribution is represented by what we call a density curve. Density curves don't have to look like this, but it's a special type of density curve where there are a few characteristics that are special for the normal distribution. The normal curve or the normal distribution has this mound shape and symmetric curve that some people call bell-shaped. You might see that in other textbooks. We call it a normal shape or a normal curve. This curve is symmetric about the mean, which is always in the middle. And this symbol right here, which we call mu, is another symbol that we use for the mean. So you're used to seeing the mean as x bar. X bar and the mu both represent the mean. So under a normal curve, the mean is represented with this Greek letter called mu. Each area under this curve, by adding a standard deviation, adding 2 standard deviations, adding 3 standard deviations, and then also subtracting a standard deviation, subtracting 2, subtracting 3, they follow a pattern. In some statistics textbooks, we call it the empirical rule, or the 68, 95, 99.7 rule. And that rule basically says that the curve is going to be broken up this way. That 0.15% is going to be to the left of 3 standard deviations to the left of the mean. Between 3 to the left and 2 standard deviations to the left, we'll have 2.35%. Between 2 standard deviations to the left and 1 standard deviation to the left, we'll have 13.5%. Between 1 standard deviation to the left and the mean, we're going to have 34% of our data. So our data is going to be broken up this way, and the right side is symmetric, so those same percentages you want to have on the right side. I would recommend that you have a good sketch of this, big graph sketch in your notes, so that when we get to questions where you can use these percentages, you don't have to go back and hunt for it. You've got that one piece of paper that you can kind of use for these questions. And the normal curve always follows these percentages, at least rounded to those percentages. Now I should notice that the total area under the curve is 100%, which as a decimal would just be 1. So if we're using decimals instead of percents, the total area under the curve is 1, and this would be 0.34, 0.135, 0.0235, 0.0015. For example, here's our normal curve. It's the same curve we had just a second ago. If I know that the mean is 65, the mean is going to go under my curve right in the middle. So this mu here represents the mean. So instead of 0, I could put a 65. And the standard deviation is 2. So what I'm going to do is I'm going to add 2 to 65. 65 plus 2 is 67. I'll add another 2, another standard deviation. 67 plus 2 is 69. I'll add another standard deviation to get the next number. And I only want to go 3 places to the right of, or 3 standard deviations to the right of the mean under my curve. To go to the left of the mean, I'm going to subtract the standard deviation. So in this case, I'm going to subtract 2, subtract 2, subtract 2. And that's how I fill in these numbers under the curve that correspond with these spots under the curve that help us separate our percentages up. Here is an example where I have a curve and it is shaded, and I want to know the area under that curve that's represented by the shaded region. Well, if you go back to your picture that we drew in our notes, this little sliver over here is 0.15%. 0.15%. The next little section was 2.35%. The next little section was 13.5%. And the next section to the left of the mean is 34%. if I add all four of these shaded sections together, I get the area of the entire shaded region. And some of you just looked at this and you may have already known that the answer is going to be 50%. As a decimal, that would be 0.5. So the area under the normal curve could be represented as 50%, but usually we'll use a decimal and we'll say that it would be 0.5 or half. In our next example, we want the area under the curve represented by the shaded region. We're going 1 standard deviation to the right of the mean. So remember, here's the mean right there in the middle. We're going from 1 to 3. So these two sections we need to get the area of. So we'll go back to our drawing and say, well, this area is 13.5%. This area is 2.35%. We put it together to get 15.85%. As a decimal, we move that for percents. You know, if that's our answer, that's our answer. But if we want the decimal version, we would move this decimal 2 places to the left to get 0.1585. All right, so here we have a normal distribution that has a mean of 18 and a standard deviation of 3. We're going to find the probability that a randomly selected x value from the given distribution is in the interval between 12 and 18. Now, I'll pop the graph up, and I want to say this graph does not represent, the shading does not represent these numbers because I kind of just borrowed this graph from earlier. It was already shaded. So we're going to add our shading to the graph. So we're going from 12 to 18. So that includes the area in this section, and it includes the area in this section. So this is our shaded section here between 12 and 18. So we want to, of course, go to our picture and notice that 13.5% represents the area from 12 to 15. That's 2 standard deviations to the left to 1 standard deviation to the left. And 34% represents the amount of data that would be between 15 and 18. Added together, that's 47.5% or 0.475. So you can see if you have your picture in your notes that you can easily go back to and grab those percentages. Answering these questions is as easy as adding the right numbers together. The next question says, well, what is the probability that we would get a randomly selected x value that is at least 21? And I should point out, remember that probability is always between 0 and 1, and the area under this curve is between 0 and 1. So when we find the area, we are finding the probability. So again, the shading of the picture isn't going to match. We're going to have to add our own shading. So the correct shading would be from 21 to everything greater. At least 21 means that's the smallest. So this section here, we're going to have to find the area of. This section here, and this tiny little section over here. Okay, so you might be at the point now where you're going, oh, I remember that's 13.5, that's 2.35, that's 0.15. And if you're not, then go back and look at your picture and grab those 3%, add them together to get 16%, which is about 0.16. What is 0.16? But the area under the curve is about 0.16. So the probability is about 0.16. You try these. Pause the video, and then I'll pop up the answer in just a second, and you can check your answer. All right, so if you want to find the probability that you get at most 12, you absolutely should draw a curve every time. Do your best job to draw the curve. At most 12 means that the highest it's going to be is 12. So really, that's saying less than 12. So you should have the left side shaded. And you would add 0.15 plus 0.235 to get 2.5%, or 0.025 is the probability that you're looking for. Try this one between 9 and 21. Again, sketch your graph. Make sure you put it, when you answer these questions that you sketch your graph. We're going from 9 to 21. So we got all these areas, and I will, hopefully you'll pause the video, try it out, and see if you get it right. All right, the answer that you should get is 83.85%, which is a probability of 0.8385. All right, so question 4. The heights of 3,000 women at a particular college are normally distributed with a mean of 65 and a standard deviation of 2.5. What percent of college women have heights below 70 inches? Okay, in order to answer this, we really need to get a picture. So we're going to do our best to sketch that normal curve. I know yours won't be perfect. You just do your best. The mean is in the middle, and the mean is 65. We've got to go 3 standard deviations to the right. We're going to add 2.5, so that's 67.5. 2.5 more is 70, and then 72.5. So that's the mean there in the middle. 1, 2, 3 standard deviations to the left, we're going to subtract, so that's 62.5, 60, and 57.5. So once we get that under there, we want to go below 70 inches. So 70 is right here. Below 70 is going to be this section, this section, this section, this section. Lots of sections that we're going to add together, right? Now, one way to do this is to add 0.15 plus 2.35 plus 13.5 plus 34 plus 34 plus 13.5. Add all of those sections together. You can, if you want to, realize that the area under here is equal to 1. So if we find this little part right here, which is 2.35 plus 0.15, which is 2.5, we add just those two together, we can subtract from 100% in order to get the percent to the left. So either add up what you're looking for, which is below 70 inches, or find what you're not looking for and subtract from 100%, or if you have decimals, subtract from 1. The correct answer is 97.5% is the percent, which remember is all of those added together, or 100 minus 2.5. Our next question. All right, so I had to erase the curve there, so hopefully you already have that down, about how many of the college women have heights between 60 and 65 inches. And unfortunately, I'm going to have to draw that thing again, so I'll do that really quickly. All right, so we are looking for the number of college women who have heights between 60 and 65. Now, we want this area and this area together. So do you remember what this 0.15, 2.35, this is 13.5%, and this is 34%. And altogether, that is going to be 47.5%. Now, it doesn't say what percent, it says about how many of the college women. It's 47.5% of 3,000. So we're going to use this as a decimal and say 0.475, which is the decimal version of 47.5, of or times 3,000. And that should give us our answer, which is 1,425 women is about how many we would expect to be in that height range. If you look back in your notes at the curve that we've drawn, what you'll notice is that to answer this question, we have a problem. 71 inches is not one of those special places under the curve, because remember, we had 65 in the middle, and then when we went to the right, it was 67.5, 70, 72.5. Well, 71 isn't one of those special places, and that means that we are not able to use those percentages when we get a question when that number that we're looking for is not on the curve. And instead, in order to find the probability or in order to find the area under the curve, we're going to have to use our graphing calculators. So at this point, you want to get out your graphing calculator. And on your graphing calculator, we're going to talk about how to use this command called normal CDF. Now, to use normal CDF, these are the commands that you're going to look for. When we say that x is less than some number, we're basically going to, this is our lower boundary. Negative 1e99 is a really large negative number. It's negative 1 with 99 zeros after it. It's the largest negative number that our calculator can handle. That's our lower boundary. It's like saying negative infinity. It's the best that we can do in our calculator. K is going to be our upper boundary. Because we're shading to the left, that is kind of like we're saying everything to the left, everything less than that spot. So that's our upper boundary. Then we have our mean and our standard deviation. And we'll look at some problems like this in just a second. For greater than, in these cases, we are looking at area that is shaded to the right. So our lower boundary would be K, the number, whatever it is. And our upper boundary is the biggest number that our calculator can handle. It's the best that we can get towards infinity, and that's 1e99, which is 1 times 10 to the 99th power. It's a huge number, comma mean, comma standard deviation. And then finally, if we are looking between 2 points, this is x, what's the probability that we get an x between h and k? We're going to use normal CDF, but the lower boundary and the upper boundary are going to be given to us. Now, if you have a newer calculator, it's possible that it might ask you questions rather than you having to type it in this way. It might say, what's your lower boundary, what's your upper boundary, what's your mean, what's your standard deviation. And if you have questions about how to use your calculator in class, please just stop me and ask, and we'll work through it. So let's look at this question, number 5 here. A particular leg bone for a dinosaur fossil has a mean length of 5 feet and a standard deviation of 3 inches. What is the probability that a leg bone is less than 62 inches? So you'll notice that if we have a mean of 5 feet and a standard deviation of 3 inches, these don't quite match up. So let's convert our mean from feet to inches. So we'd multiply 5 times 12 to get a mean of 60 inches. So that's kind of the first thing you want to make sure that your units are all the same. And when you look at 62 inches, it's not 1 standard deviation away from 60 inches. It's a little less than 1 standard deviation. So we're going to have to use this new method of using our calculator. So to find the probability that we get a leg bone less than 62 inches, we're going to use normal CDF. Let's get our graphing calculator out so that we can kind of look at how to put this in the calculator and where to go and how to find it. In order to get to normal CDF, you want to look for something in your calculator called DISTR. DISTR stands for distributions, and this is a normal distribution. You hit second distribution. The first one, PDF, we are not going to use for this class. You wouldn't use it in an AP class either. It's just, it's not going to be useful for us right now. But normal CDF is the one we want to use. That's the second choice. When you choose normal CDF, you need to put a lower boundary and an upper boundary. You'll hit -1. E is actually above the comma here. So you have to hit second comma to get E. You'll notice it's a little small. 99. Again, remember that's the lower boundary of negative infinity, at least in our calculator. Comma, it's right here. 62 is our upper boundary because we're less than 62. That means we care for everything that up to 62 but not past 62. Comma, the mean was, remember we said that 5 feet is a mean of 60 inches. And a standard deviation in this case of 3 inches. Lower boundary, upper boundary, mean, standard deviation. Hit enter and you get the probability, the area under the curve. In this case, it's 0.7475 about. It might help you to sketch the curve. So I know 60 is in the middle. I know that 62 is to the right of that. I'm shading to the left. So my lower boundary is a really big negative number, and my upper boundary is 62. The weight of chocolate bars from a particular chocolate factory has a mean of 8 ounces with a standard deviation of 0.1 ounces. What is the percent that a randomly selected bar is between 7.85 and 8.15? This is a between question. So we're looking for the probability that we get a value between 7.85 and 8.15. We're going to use normal CDF here, but our lower boundary and upper boundary are already given to us. So we don't have to use that -1e99 or +1e99. So we got lower boundary, upper boundary, mean, and standard deviation. And I'll remind you that the calculator to get here, you hit second vars. And it's really not vars that you're interested in. You're interested in the secondary command, which is DISTR, which stands for distributions. So we want the normal distribution. And then you choose normal CDF, you plug this in, and you get an answer of 0.8664, right? That's what your calculator would give you. You'd have to round it. And you would convert that to a percent by moving that decimal 2 places to the right to get 86.64%. Is the percent of randomly selected chocolate bars that would weigh between 7.85 ounces and 8.15 ounces. Let's look at one more question. It's got multiple parts. What grades on a statistics midterm exam were normally distributed? The grades. Let's look at one more question, number 7 here. The grades on a statistics midterm exam were normally distributed with a mean of 72 and a standard deviation of 8. What proportion of students received a B grade? We are going to classify a B grade as being between 80 and 89. We'll assume that if it was a grade a little bit higher than 89, the teacher would give you an A. So anything from 80 to 89 is going to be considered a B. We're going to use normal CDF between 80 and 89, lower boundary, upper boundary, with a mean of 72 and a standard deviation of 8. And that will give us the percent of students that earn a B. In this class, it's going to be about 14.19%. The proportion is 0.1419, the percent is 14.19% received a B. If this were a test question and you said from 80 to 90, I would give you credit. I mean, that wouldn't be wrong. Or if you said from 79.5 to 89.5 and you found that under the curve, our percents would be close. They might be a little different. You could still get this question right because there's a little bit of interpretation here as to what constitutes a B. The second part, B, says, what is the probability that a randomly selected student receives between a 65 and an 85? Well, this is a little bit more straightforward. We've got our lower boundary and upper boundary. So we use normal CDF between those two with a mean of 72 and a standard deviation of 8 still. And we get 0.7571. So most students in this class scored somewhere between 65 and 85. And part C, the question that many students want to know when they take an exam. Well, what percent of us fail this exam? And for you guys, it's usually very low. Most of you do really well on the exams, and that's great. In this class, we're gonna classify someone failing the exam as making a 69 or less. If they make a 69.4 or 69.5 or 69.6, I'm going to give them credit and just bump it up to a 70 because, I do that sometimes. But if they make a 69 or less, that is going to be considered failing the exam. So in this case, this is one of those less thans. So our lower boundary has to be a really big negative number. Our upper boundary is 69. Our mean and standard deviation have not changed. We put those into the calculator and we get 0.3538. And you'll have to round it 4 places past the decimal. Well, that's 35.38% when you convert it to a decimal. So a good percentage of students failed this exam, unfortunately. Hopefully that won't be true for you when you take your Unit 6 test a little bit later in this semester. Well, that is it for today. I hope this makes sense at least a little bit and that you are successful. As you're practicing in class, please ask me questions if you've got them. I'll be glad to help you.